Moving on to the next testing scenario. This scenario will test function called end-of-hour. And what this function is doing is it basically accepts a date object. Let's say we have passed a date with a time of 8:30 p.m. And this function will basically return the same date, but an hour will be changed to the next one. So instead of 8:30 p.m., it will contain 9 p.m. But the date itself will remain the same. And also please note that this function does not modify the past object, but instead it creates new date object. So in the first part of the test where we're preparing the data, we're gonna create two date objects. First one we're going to pass into end-of-hour function, and the second object will be the one we're going to compare the result with. And since our first date object has time of 10:15 a.m., the second one should have time 11 a.m. So besides incrementing an hour, it also drops amount of minutes. So now in the third part of the test, I'm going to write an expectation, call the function end-of-hour, and pass first date object. And then I'm going to compare this result with the date stored inside end-of-hour constant. But the thing is that end-of-hour constant is called the same as end-of-hour function, so we have to rename the constant. I'm going to use end-of-hour date. And if we're going to take a look at the test results, sure enough we'll see that the test is passing. But the moment I'm going to change an hour of the second date, for example, let's use 12, right away we're going to see an error in the terminal. Let's revert this change and try to modify implementation of end-of-hour function to make sure that if implementation is broken, test is going to let us know about it. This test is still failing, so it's good. Now I'm going to go back to the test file and add a couple more date objects. So we're going to have date A, date B, and date C, and corresponding end-of-hour objects to compare results with. In here I'm using random dates for objects date B and date C, and end-of-hour constants should contain those same dates, but with our incremented. If the date B object has 8 p.m., the end-of-hour B object should have 21 p.m. And if date C object has 12 p.m., the end-of-hour C object is supposed to have 1 p.m. Let's duplicate this expectation and use it 2 more times. In the second case, we're passing date B and expecting end-of-hour B, and lastly, we're passing date C and expecting end-of-hour C. And all our expectations have passed. Moving on to the next testing scenario. It checks if past date is today. So this testing scenario is going to be used to test function with the name isToday. This function accepts date object, and it basically checks if the past object corresponds to today's date. So for this test, we're gonna need only one piece of data. I'm going to declare date A object, which is going to be a random date. And then to make sure that isToday function works properly, I'm going to expect that the return value of this function is supposed to be equal to false, because the date stored inside date A object isn't the current date. And the test is passing, but what if we're going to mock the current time by using setSystemTime function and passing date A object? In this case, date A is current date, so isToday function is going to return true. And because of this, our current test fails. So in here, let's change this value on true. And to have some extra guarantees, I'm going to create another date object, date B. Let's also use a random date for this one, and duplicate this expectation. Instead of date A, we're passing date B into isToday function and expecting the result to be false, since it is not the current date. So the test is passing. Now I'm going to copy these 3 lines, paste it one more time at the end of the test, and here I'm gonna do the opposite. I'll set system time to be equal to dateB object. Then in the first case, we're expecting that isToday function is going to return false, and in the second case, when we are passing dateB to isToday function, it is supposed to return true. And of course, since we have mocked current date in this test, we have to reset it at the end. So let's use real timers in here. Just to be extra sure, let's modify implementation of isToday function. Instead of comparing the date with the current date, I'm going to compare the past date with tomorrow's date. In this case, test is supposed to give us an error. And as we can see, it's throwing an error. So now I'm gonna revert this change, get back to the test file, remove the modifier only, and now we're getting to implementing the last testing scenario in this file. This scenario is going to test function with a name 2 seconds. The purpose of this function is pretty simple. It just takes amount of milliseconds and converts them into seconds. As you can see here, we have a simple formula for conversion. So get back to our test and write expectation. I'm gonna call it 2 seconds function, passing minus 10,000 milliseconds. In this case, the function is supposed to return minus 10 seconds after conversion. And then I'll add a couple more expectation. In this second case, let's pass minus 1000 milliseconds. We'll get minus 1 second. And let's also use 0. In this case, we're also going to get 0 back. So all these expectations are passing, but if we'll change implementation of 2 seconds function, we're going to see them failing. Now I'm gonna revert this change, get back to the test, and add a couple more expectations. In the fourth case, we're passing 1000 milliseconds and should return 1 second. And lastly, after passing 10,000 milliseconds, we're about to get 10 seconds. And all expectations are passing. At the end, let's also run all tests. I'm gonna remove modifier only and check results in the terminal. As you can see, all tests in the projects are also passing. Let's continue in the next lesson.